All right, mixtures. Again, example 2. So in our first example, we set up a system of equations to kind of use some information. And this is from slide number 1, or sorry, video A. We're in video B. And we set up some information based on the information that we were given. The trick was that we had to use the idea of, hang on a second. Alright, well, let's see. Trick is we had to use the idea of the amount of liquid that we had and the amount of chemical that we had. Liquid becomes one equation, chemical becomes another equation, and we had to think about what we start with, what we added, and what we got. They give us some information, 30 liters goes here, and we calculated 6 here by multiplying 0.2 or 20% times 30 to get 6. And then the same token holds true here, the same token holds true here for the 0.4y. And then we set up our system of equations. So we're going to do pretty much the same thing over here with a different, similar but different application. So it's a similar but different question. Question is, how many ounces of 20% and 35% acid solution should be mixed together to obtain 15 ounces of 30% acid solution? All right, so let's see. The question asks, how many ounces? All right, so you know what? We've got to define. In mathy terms, we'd probably say, let x equal such and such. But this one, you know what? We can just define our variables. Define x as amount, I guess, let's see, amount in ounces of a 20% solution. Because we're gonna again think of a big picture. We're gonna take some 20%, we're gonna add some 35%, and we're gonna obtain a 30% solution. So we need to know how much 20% solution we're gonna get, because we know they told us the number of ounces we're gonna get of 30% solution. Our y variable, and you could use a and b, you could use whatever, but x and y is something that we've been commonly using. Amount in ounces of, and these are ditto marks, hash marks, of 35% solution. I guess I'll put solution up here, solution up here. All right, so we've defined our variables. We've got to kind of know where we're going before we kind of try and get there. So we've got to find out what x is and what y is. We've got to set up a system of equations. And how do we do that? Well, we know that we start with 20% over here, a column for 20%, because we're starting with some 20%. We're going to add some 35%, and we're going to get a 30% solution. And that's all from right up in here. How many ounces of this plus this do we mix together to get 30%? This plus this gives us that. All right, so now we set up our little rectangle, our table. We say, all right, here's the information that I've got. What do I start with over here? I've got to have, in the previous example, it was gallons. I think it was gallons. Or sorry, it was liters. Here, it's ounces. So the amount of liquid that we've got, ounces. Let's see. And let's see. And you know what? We'll keep, I was thinking about what color I should use, but I'll use colors in here. All right, how many ounces do we have? How much chemical? So you always think about how much liquid you got and how much chemical you got in terms of mixture solutions. So if we now think about what information we can put in there. Hang on a second. I don't know why this is doing this. All right, there we go. We're back. Let's see. So we've got to figure out what information we can put into the table from the information that we've got up here. So I will say the number of ounces that we have here. Well, we've defined it as a variable. Amount of ounces of 20% solution. Well, that's x. Amount of ounces of 35% solution. That's y. Ounces of 35% solution. That's y. And then 30%. They're telling us right here. We're going to have to make 15 ounces of 20% solution. So right here goes 15 ounces of 30% solution. So there's 15. And pretty much now we've taken all the information up here and we put it in down here. So the only thing that's left is to do some calculations, some kind of minor calculations. 30% times 15 is 0.3 times 115. Sorry, 0.3 times 15 is 4.5. And I changed colors because this green is going to be one solution or one equation. The red's going to be another equation. So what goes down here? The amount of chemical that's in here, it's 20% of x. 20% is 0.2 times x. So this is 0.2 times x. You could put 0.2x as well. But just to save some space, we'll put 0.2x. This is 0.35 times y, because we had y ounces, and 35% of it, or 0.35 times y, is chemical. And now we've got a system of equations. We have a system starting with x plus y equals 15. We also have the second equation as 0.2x plus 0.35y equals 4.5. And now we've got a system of equations. The red and the green equations come from the information that's in the table. And now, how do we solve it? Well, we've got three different ways. I do not recommend graphing, so you've got two different ways. Number one, substitution. Number two, addition or elimination method, whichever one you want to call it. I'm going to recommend probably for, I'm going to guess most of these, probably not using substitution, because when you define x or y here in terms of the other one, if you, in other words, if you call this x equals 15 minus y, you've got to put that down here, and you're starting to deal with some odd multiplications. So I'm going to say let's just multiply. I would recommend probably multiplying the red equation by something to eliminate one of these, probably the x's or the y's. I'm going to say 0.2. If you multiply that by, let's see, 5, you would get 1. And if you multiply it by negative 5, you'd get negative 1, and that would be the opposite of this positive 1 up here. So I'm going to recommend multiply by negative 5, and I'm kind of crunching things together to save some space here. Alright, let's see what we get here. If we multiply by negative 5, 0.2 times negative 5 gives me negative 1x. 0.35 times negative 5 is, let's see, I've got to pull out the calculator for that one. Negative 1.75, negative 1.75 y equals 4.5 times negative 5 gives me a negative 22.5, I believe. Yes, 22.5. So that negative goes to the 22.5. I'm really crunched in over here. Alright, and now all we have to do is rewrite the x plus y equals 15, and we've pretty much got our system all set up. So now if we use the addition method, this coefficient is 1, this coefficient is negative 1. When we add these up, this goes away, the x terms go away. Add the 1y plus the negative 1.75 gives you negative 0.75y equals 15 plus a negative 22.5 is negative 7.5. And if we divide by negative 0.75, divide by negative 0.75, we get y equals 10. So if y is equal to 10, then we can go back up and go from y equals 10 and kind of look at this and say, well, y is 10. We get, sorry, yeah, 10 here. That has to be 5 because x equals 5 because add them all up. Sorry, that was a little bit unclear. Let's see, x equals 5. And then we just go back and double check. 10 plus 5 is 15, sure enough. And then do your multiplication of the red equation and say 0.2 times 10 is 2. 0.35 times 5 is, pull out a calculator and do that one. 0.35 times 5 is 1.75 plus 1, let's see, oh god. It's getting late, so guys, sorry. This would I would double check the work, and I would say that it would work so assume that it's going to work. Y equals 10, x equals 5.